Good morning, everyone. I think we had so far 3 very interesting panels, and it's going to be a challenge for all of us to make this panel as lively, as interesting as the other one. So I count on you, of course. One thing I can take away from the 3 preceding panels is that they show something in common. That is that the aviation landscape is changing very rapidly, and it was quite fascinating to see from those 3 angles of attacks all the changes that are coming, and that we have to manage, and that will impact the way we work in aviation. In the first panel, we've seen how much technology can improve safety. There was one very interesting thing that I've seen on the presentation by the colleague from Airbus, the automated emergency descent, which is one step further into the automation of flight. And I was thinking, and maybe we'll have the response during this panel, so how this will further impact the skills of the pilots, and how to keep up with this further automation. In the second panel, we've seen how much new threats and how rapidly new threats can come now to our aviation system, how fast they can proliferate, and how fast also we need to react. And here again, there is a clear implication on how in the cockpit or in the control tower we need to manage those new threats. So there is a question of how much adaptable we need to be in our roles in aviation, especially for the 2 I would say most safety critical role in aviation, which are the pilots and the air traffic controllers. And in the third panel, we've seen also how much the public expectations bring a further pressure to accelerate those changes, and this having again an impact on with those new technologies being brought, new types of aircraft, new types of operations, how this will in turn also impact our jobs. I was also interesting to see from the presentation that from Marwan on the bottleneck in ATM that we experience every summer. That one of the response is also further automation, in particular in the relationship between the air traffic controller and the pilot. And but I liked very much the word that you said also, Marwan. Where is Marwan? Hi, Marwan. Is that what you want is to keep the human at the center, and that the idea with automation is to augment the human capacity, to enhance the workforce and not to replace it. And I think that's one of some of the fundamental aspects that we are going to explore during this panel. The question being, so with this increased reliance on automation, which is further, I would say, accelerated and amplified by the use of artificial intelligence, how will this impact our job, our roles, our skills? And how can we make sure that we use technology to enhance the workforce rather than to replace the workforce? So to help us understand this complex and, as we can see, multifaceted issue, we have a very distinguished panel here with, I think, a wealth of experience in the different domains. So I'm starting with from the left to the right, with Captain Paul Reuter. Paul, you are Vice President of the Eurocockpit Association. You are also captain on Boeing 737. You are very well known at EASA because you've been involved in many of our developments. I remind your role in the German winning task force that we set up in the wake of the accident. You are also a member of our Data for Safety program steering board, and you are also involved in just culture development. And then Dr. Stathis Malakis. Stathis, you are an experienced air traffic controller with the Hellenic Aviation service provider, where you had the ATC safety management system section, but you are also a scientist. You have a PhD in safety and cognitive system engineering and a deep research background with quite a lot of publications. And also you are specialized in system safety and AI applications in ATC. Then Mihály Kurucz, sorry if I don't pronounce your name very well. You are currently Director of Safety and Quality Management and Internal Audit at Hungarocontrol. I think we can say you are a veteran in air traffic control because you have more than 40 years of experience, first as an air traffic controller, and then in a management role, and in particular, you had a crucial role in the development of the integrated safety and quality management system at Hungarocontrol. And on top of that, you're also a member of the Eurocontrol safety team and the Council Safety Standing Committee. And then we have our usual suspect on artificial intelligence, Guillaume. I think that everyone now knows Guillaume, so I don't think it is necessary to introduce you, and we'll welcome again your views on the aspect on how AI supports automations. Now that the introductions have been made, Paul, I give you the floor for the first presentation, and we will welcome your insights on the implication from the pilot and the flight crew point of view.
Thank you, Jean-Marc. And thank you to EASA for inviting us, and of course also to our Hungarian guests for this great hospitality. So yeah, I prepared a short 25-slide presentation with animations on AI and the socio-economic challenges. So for us, there's a couple of caveats that we would like, as when we talk from the pilot perspective and probably from the workforce perspective, what we think is important. First one, of course, is that AI must improve current safety levels. I think that should always be the aim with all new technological innovation, is that we move forward also when it comes to safety levels. And of course, for us it's clear that the human must remain in charge. AI can only be a tool, and it should be seen as such. As such as well, I think what is very important that we avoid the personification of AI. Is something that Hollywood is very good at. They put AI and then it has a face of Will Smith and it has puppy eyes and we get very sentimental. I think it's something we should really do, because I think the human needs to understand that it's a tool and there needs to be a gradient on how we approach this. And there cannot be any ambiguity on how AI is introduced and operated in the work environment. Human and AI interaction, of course, it needs to be very clearly defined and needs to be balanced in favor of the human when it comes to accountability, to responsibility, and to final decisions. And the complexities of AI involvement, they need to be assessed and reduced to a minimum. We're going to introduce AI. It's going to mess with the way that we work. It's going to mess with the perception of how we see AI. And there's going to be, and we're going to need to address these things properly. And I'll come to training later, but that will certainly also be a big impact. Again, this I said already, it can only ever be a tool. As a tool, AI should provide optional courses of action, support to situational awareness, and I think that is where AI actually can help us. It is by helping our situational awareness by possibly suggesting courses of option that we might not in a crew immediately think, because we have to deal with quite a lot of information, especially in critical situations, and we might sometimes miss some hints, some cues, some information, and I think AI can play a role in structuring that and possibly giving us hints or supporting our decision making. And of course, these options need to be understandable and relatable to us as humans, so that we can actually decide on a course of action. Basically, whatever comes out of AI, of that tool, it needs to be in a format that a human or a crew of humans, possibly under a stressful situation and maybe close to information overload, may still understand the context and understand the value of the information that is given and can treat it in that way. Again, as with automation, AI will require more training and possibly a different approach to initial and recurrent training, especially to air traffic controllers and pilots, I guess. And yeah, we've seen that automation is great. It takes away a lot of our workload if it functions. Once it does not function, we need to understand, and we need to have a better understanding of what is behind the system and what makes the system function, so that we can identify the issues and we can properly assess the risks. So it will require us to be more proficient in the tools of AI and in these different tools that will be at our disposal. Again, the human must remain in charge of all safety-relevant decisions, and override functions must be in place. I think that is very important. I think whenever a safety decision is taken, it needs to be the human, also because there will be decisions where probably the empathetic side of the human will still be needed. When we talk about medical emergency on board during flight, you wouldn't want AI to take the decision based on your age and your net value to the economic system to take the decision whether to continue or to divert. And finally, and this is very important, whatever tools and whatever AI we introduce, in the end, we should do it in such a way that we still need to provide purpose and value for the human in the system. The human is still and will be for years to come at the center of our safety system. We're not safe only because we have great technology and procedures. We're safe because, as we speak, thousands of people around the world, from ATC controllers to ground handlers to pilots possibly, are producing safety every day under sometimes complex and difficult environments. And I think we need to make sure that we still provide whatever tools we give the human, we still provide in our industry purpose and value, so that we can also, and this is another issue, and I think it's going to be after this panel, so that we will still be able to attract the young and manifold talent that this industry needs to face the challenges in the next decades. So finally, AI, it's a little bit like accountants. They're very useful for specific tasks, but you wouldn't want them to run your airline, right? Some guys got the joke, excellent. So I thank you for this. Thank you for your attention.
Thank you. Thank you, Paul. Thank you very much. Stathis, down to the ground now, Stathis, with you.
Okay. I get a little bit here. Hello, everyone. Can you hear me well? I think yes. Okay. I would like to welcome everyone and also to thank the Hungarian colleagues of us for the excellent opportunity, and also the EASA for the hospitality. I'm going to say a few things about the socioeconomic challenges for the aviation community, speaking from the perspective of IFATCA. And what is IFATCA? It's the International Federation of Air Traffic Controllers. This is the global voice of air traffic controllers. And our mission is to enhance air traffic safety, to promote the air traffic control profession and to save the future of the air traffic management. We are a global organization and we are also a professional organization which unites more than 130 countries and 45,000 and above air traffic controllers. So, what is our philosophy? We want technology that serves air traffic controllers and not air traffic controllers that serve technology. This is our philosophy, and it was the very first philosophy from the time the first air traffic controller got out on the control tower and controlled the first air traffic. We want always to be in control. And because we are an invention of the air travel, because we, in the first few years of the aviation, we saw that if you leave the aircraft alone, they tend to collide itself. So we invented the air traffic controllers, and that is why we do from the radar, for the AI, for the CNS systems and everything. We want technology that serves us. What we have done so far as a FRAeS, we produce a guidance material, research paper, conference paper, participation in EU project, collaboration with stakeholders, just like being here and trying to voice out our concerns. We are not technophobic, but we want to proceed with caution. We are not against AI, but we want it to be at the center for the air traffic controllers and to serve them. So what we view the AI and machine learning, and now I'm going to say something about AI and machine learning. We view them not as a tool, actually, but as an environment. As we say, we have our tablet, our laptop, our smartwatch, our smartphone. This is an environment. It will be an environment in which the future operation, the air traffic control towers, the operations room, the area control centers, the terminal radar control centers, they will work with AI and machine learning. And I will make a difference here because I want to, let's say, go a bit farther about what is AI and machine learning. If you have, for example, I will give you a small example. If you have an elevator, this is just an automation. You press the button, you have the elevator calling. If you have an elevator that waits at the floor that the most people are waiting to use the elevator, that is AI. And to do that, you use machine learning. You have a very long function, an equation to optimize. I will give you also another example. You use ChatGPT, I use ChatGPT. ChatGPT 3.5 has 175 billion parameters. That's a whole lot of equation with all these parameters. And also, ChatGPT 4 has 1.6 trillion parameters. So this is AI and machine learning. And now we have the capacity, the computers, the memory storage, and everything that you can run them. So what we do and what we are expecting is that we have the human AI teaming. This is a very difficult task because up until now, human factors literature has, let's say, was in the main focus of human-human teaming. But now we have intelligent things. On the other side, is the AI is something that learns. You can see it as a learning algorithm. And it's not unusual for the aviation because from the very moment we have the first flight in aviation, we kept learning. That's why we achieved the ultra-safe status we have right now, because we were learning. So we have a lot of open issues. First of all, we have the value alignment problem, which is ensuring that AI, what we program is what we want. I will give you an example based on the network manager or whatever. If you have, let's say, a traffic planning algorithm about touch, slots, and everything, and calculates the right slot, and then the aircraft departs at the time the AI says, but it requests a direct routing, and it saves the delay that was grounded the aircraft. So this is not actually very intelligent. So you have this problem. You try to align what you want as a air traffic controller, as a pilot, as a maintenance engineer with what AI and machine learning can do. The second one is just culture issues. If you have, let's say, a system with 175 billion parameters, and it makes an assistance, a recommendation, and everything, and the air traffic controller, the pilot accepts this, who is responsible? So right now, we have just developed the just culture in order for the conventional system to work properly. But if you want the flow of information to go through the safety management system and you have the safety information keep running, you have to say who will be accountable when you have an algorithm that is very complex. The third one is something that all the previous said, staying in control, maintaining situational awareness, and not only on the normal operation. We see a lot of AI machine systems, and I have been involved in projects where the conflict resolution predicted it was good for an area control center. But when it comes to another area control center, it doesn't work because the air traffic controls, the aerodromes, the terminal areas, the sectors are not the same. You're not flying a Rafale. You're not flying a Rafale F3 or an Airbus A350 and it has the same performance everywhere. Every aerodrome is different by its own means, and this is not easily codified, algorithmicized in a machine learning on an AI algorithm. So we have the skilling issues. The skilling issues. We try to see what happened with the aviation in the 80s when the new aircraft with the fly-by-wire, the automation and everything, and we try to avoid to make these mistakes in the air traffic control. Because if you have to introduce automation, you introduce new types of errors. You need new skills. You need to think above what are the normal errors that a air traffic controller can do in a new environment. Also, we have the managing the social impacts, addressing relocation, mobility, and community implication. If you have, for example, virtual ACCs, remote towers, or whatever, we have the relocation issues, and we have a large task force to deal with and also to provide the means for them in order to have an incentive to relocate. We also have resistance and job security concerns. About AI, a lot of air traffic controllers are fearing about their jobs because it's a generation gap. If you have air traffic controllers trained in, let's say, 20 years ago or 15 years ago, they are not get used to the new technologies. They are not versed in these technologies, and they are reasonably fearing about the future because they have to develop their digital skills in order to remain competent in the new environment. And also, the last one, but not the least, we have demand for new knowledge and skills, developing expertise suited to AI-enabled applications. We see the AI as something like in the 50s when the radar was introduced in the air traffic control. At first, the air traffic controllers, they were using symbols, something that was having a flag on it and going from one place to another, using HF communication to communicate, to take the bearings and everything. And then it came the radar. You have a rotating screen with blips and everything. You have to get used to it. But the air traffic controllers managed to do that, and we provide safe radar service right now. So we think that AI will be a new, let's say, environment in which we have to train the new generation of air traffic controllers in the concept, just like about the basics of AI, what can go wrong, the data dependency, the bias variance trade-off, and everything, just like we trained the first batch of the air traffic controllers back in the 50s about the primary surveillance radar, the secondary surveillance radar, squawk, and everything. This is something we are going to make it as an air traffic control community in order to provide the safety, the expeditionless and the orderliness of the air traffic controller that the air travel demands. Because at the end of the day, in Europe and everywhere in the world, people want to fly from place A to place B with safety. And the air traffic controllers represent another AI in the equation for this transportation. It is the adaptive intelligence of the system. Whenever regulations, procedures, systems fail, go out of work, be ambitious, not regulated and everything, they are the air traffic controllers, and a part of them, the pilots, must compensate for these deficiencies. Thank you very much. That was all for me.
Thank you very much, Stathis. And I think your last slides really captured my attention, because we had the discussion in the last panel on the slow pace of innovation, and I think that all the challenges that you show and the need to keep the human at the center of the approach, so that I mean, automation, AI is not something that you implement just because you decide. Yes. You have really to take care of all these aspects, because you can't be disruptive with the human aspect. You have really to progress very, very carefully, step by step. Thank you. It's for you, Mihály, now to take the floor with now your point of view as an air navigation service provider. Thank you.
Thank you very much. Thank you for EASA inviting Cluzeau to this panel. And thank you for my colleagues presenting before me, because probably they spoke everything I wanted to tell. But my voice be a bit monotonic after a while. I consider myself human. So please don't think I'm an artificial intelligence or something else, a top product of such industry. So first, I want to recall or introduce you the white paper made by Cluzeau. This QR code is not for the Slido. It is the link to this white paper. And Cluzeau is a global organization of air navigation service providers. We have 96 members, and this membership handles 85% of the traffic, of the airline traffic over the world. And we have 98, more than the normal members, 98 associate members from the industry. Those industries who are leading the technology and assist us to perform our task, provide enough capacity in the air for the airlines and ultimately for the passengers and the cargo to reach their destinations. So on the right side of this slide, you may find a short content of this document. It's not very long, some 30 pages, but these are the assumptions and the conclusions of our expert team about the AI, which will be used at the ANS. And based on that paper, I picked some low-hanging fruits which will be very implementative or which will be very easy to implement at the first glance, but on the other side I have some questions about those. So if we call the voice recognition, it can help us with the readback and hearback errors to discover, which can make a lot of occurrences, misunderstandings, and it can help us in the training as well, simulators and on-site, or I mean individual trainings. And there is another issue about the demand prediction, because as you could see, demand and weather prediction this summer was in Europe especially, I would say, kind of chaotic by the weather and the delays, and it's not new. It comes every year, the topic, and it was on the news as around Europe that the passengers were waiting at the airports and waiting for their flights. But we shouldn't forget that these queues and these delays were because of the safety. So I was very glad hearing yesterday in the opening remarks that we don't speak about the safety when we speak about the traffic jams in the air and long queues at the airports, but finally who could fly safely was delivered to the destination. So it is essential, and the air navigation services are working for that. And this slide just lists my brainstorming dilemmas regarding those AI implementations. There are pros and cons on every aspect, and I think later on this panel we'll elaborate on these aspects. And what I would like to stress with this occasion, that the safety aspects of implementing AI, we have to implement or adopt new technologies to our safety work. I mean, the data sets are or be the part of the product specification, the algorithm, and we have to somehow be sure what happens. We know why that happened. So the black box in the AI algorithms is still to have some questions and to explain, and the explainability is very important for us prior to implement it at the front end of the operation. And human-machine collaboration, we shouldn't escape from having AI implemented in our jobs, but we should do it in a manner that the adequate prudency and based on facts, we can implement safe solutions, and only with the human in the loop, having the human to have the last word or the decision at the situation, and having ourselves in control of the happenings. And finally, it is not written in that paper. It is my view that AI is here, it will happen, but it is not an overnight exercise, fortunately. So we have time, we have to prepare for that, and we shall prepare for that. Thank you.
Yeah. Thank you. Thank you very much, Mihály. I think that in your presentation you are retouching on all the key aspects of the implementation of artificial intelligence. And Guillaume, you have the opportunity to explain to us again, but from a different perspective, the implication of the use of AI, especially as concerned the human-centered approach, which is a key feature of the EASA approach to artificial intelligence.
Absolutely, Jean-Marc. Yes, thank you. And thanks to my colleagues also from the panel to set the scene, because indeed you see all the challenges from operators and pilots at cause perspective, and I think it's extremely important. So what I did indeed is to take a totally different angle of view from the AI concept paper, roadmap, and what the program is doing to precisely address this type of challenges that are, we call them ethics-based, in fact, and to make them a bit wider. And job, let's say, impact on jobs is one of the aspects that are integral to this approach. So we will not come back on the fact that we have a potential with AI. And beyond this notion that I was mentioning in my previous talk of accuracy, technical robustness, and adequate interaction that we need to set up to be successful anyway in deploying AI, there is also an element to assess, which is the ethical impact of AI at large. And that's something that we took actually from the angle of the EU Commission high-level group, who, I think it was in 2018, worked on some documents, in particular, they call it a trustworthy AI assessment list, which is a list of items to consider. It's a long list, and we started from there to see what are the burning issues that are coming, I would say, on top of what we do as a technical agency, as a technical safety agency. So after, based on that, definitely, it doesn't mean we are, EASA is a competent authority for all these matters. But the point is we are an EU agency, so it would be wrong to attack the problem and say, because this is not in our remit, we don't consider it in an assessment. Therefore, the logic of an ethics-based assessment doesn't mean, let's say, objective, concrete guidance, means of compliance, but first, an assessment. And one of the aspects, or one of the gears from this Altai is the societal impact of AI. And one aspect is definitely the impact on jobs. So because I had the floor before, I could make all the audience specialists in levels of AI, so I will not have to repeat what is level 1. It's human assistance. We could say quickly, level 1 will have little impact on operational jobs. That could be a quick statement, and then we go to the next step. But I see it also as an opportunity, in fact, to integrate new jobs. When we want to assure what I was mentioning, the system for its function, we need, with AI, machine learning, to deal with new type of job, data scientists, AI scientists, and those people need to be integrated in teams, more traditional teams of system engineers, software engineers, hardware engineers. And this is an opportunity to deploy level 1, in fact, to have little impact on operational side, on the ConOps itself, but still an opportunity to deploy these new type of jobs and integrate them in a safe mode with the existing teams. So it's a preparation in some way of organizations to deal with AI for the higher levels possibly coming. And those higher levels are definitely like level 2, level 3, as I presented this morning, will have a much stronger impact. That we can already say. So we should, as usual, jointly prepare this transition, and clearly it's under the auspices of continued safety levels as we have today, but possibly also why not increase safety levels, because that's a lot of what you were saying from the, let's say, the operational side. AI can also, why not increase safety, be a safety net for some aspects. So now moving to level 2 and on and more, human AI teaming in particular. Definitely, when you read that, you consider or you understand that there will be an impact. That's clearly the case. We cannot hide there. But to be safe and successful in the transition, it needs to be as seamless as possible. That's what you said, Mihály. We have a bit of time, and let's prepare carefully so that first end users remain at the center of the operation and do not face more difficulty to perform the tasks. Actually, are augmented, helps in the task, but not impaired in the task that is currently their operational task. And that's where the spirit of the concept paper, as I said several times, is really under the human agency and oversight consideration and angle of attack. Now, moving to this ethics-based assessment I was talking about in my introduction, we have invested some time, indeed, from this Altai and this assessment list, all the items that were there. We tried to sort out what is more technical, like technical robustness and safety. This is our core remit, and a lot has been done already in the concept paper for that. So we kind of put a traceability matrix at the end of the concept paper to say this is kind of sorted out, and it's nearly 85% of all the items that were anticipated by the expert group of the Commission. But those 15% remaining really raise questions, and you can see they are related to attachment, privacy, unfairness, or unfair bias in systems, environmental impact, very important as well, de-skilling, and accountability. And all of this is really an envelope that couldn't be just managed and tackled from a technical perspective. Definitely there is a lot to do around it, and we initiated, in fact, to keep the pace also with all the stakeholders, we initiated a survey to aviation professionals to bring with use cases, sometimes a bit ambitious use cases, maybe beyond the fence of what would be even possible, but just to trigger also the reaction and see where people are feeling comfort, trust, and acceptance of this type of automation and technology. And second, to get also some not only quantitative but qualitative feedback of people on how they see AI. So I will not make a complete debrief on the survey. You have, for the quantitative part, you have the slides from the AI days available where you can see a lot. Roughly, people were on the middle ground. Out of a scale of 7, we are at 3.5 to 4.5 in terms of comfort acceptance globally. So it means people are on the way to accept, but there are some hooks, some things to take into account, in particular those dimensions I was mentioning. And just to focus on an example, because we cannot cover everything today, but the risk of de-skilling, which you also relayed, colleagues, in your presentations. The risk is not new because automation brings possibility and risk of de-skilling, but definitely AI brings us, as we said this morning, to a next level of automation, and that's where we have to take this risk more seriously. And like for competence management in general, of course, we can mitigate it through continuous education and training programs. But we see also that with AI and advanced automation, we need to take this into account also in the design principles that we create with the guidance and with the rulemaking group that has started. So just to quick conclusion and perspective from EASA perspective, we have this notion of human AI teaming and advanced automation readily identified in the use cases that are tangible today. They are very likely and surely will impact the current jobs. We'll also have opportunities to create new ones. The key for us is to ensure this ethical adoption of AI in aviation. Again, not necessarily dealing with all the ethical aspects as part of a certification or approval, but at least having an ethics-based assessment that brings up the important issue, and some being definitely in our remit, like transparency, human oversight, accountability, which are integral part of this AI trustworthiness framework. So in preparation for the change, we need to work all together. That's the great thing to exchange in such conferences, panels, and in all the groups we have in the standardization working groups and rulemaking groups that we started. Thank you. Yeah.
Thank you very much, Guillaume. I think that this ethical dimension is AI is probably one of the aspects that is the most difficult to grab and to materialize. Though it's one of the key dimensions. Can you give possibly some concrete examples, possibly arising from the survey? Is there already some result that you could share with us?
Yes, of course. I was talking about the quantitative, but looking at the qualitative feedback we got, there are very interesting things that come out. In particular, when we raise the question, what are the next skills or the new skills that people will have to develop in the context of a human AI teaming? Some people were actually, of course, looking at training, competence building, etc., very clear. Also, of course, robustness of the technical aspects, robustness of the interfaces, very clear. But there is also the notion of emotional intelligence that was relayed, looking a bit like assertiveness was brought up, like the way to address an assistant that would enable bidirectional communication. let's say, how assertive, it's kind of verbal prompt engineering, in fact, is how do you need to manage it? You need to train, in fact, to manage this communication in order to be efficient in what you want to get out of the system as a support. So that's the type of things that are going a bit beyond even what we were considering. And maybe another example would be, we triggered again a bit, sometimes aggressively, use cases like automatic go around. And that's something from a pilot perspective, I think, Paul, you will tell. It's something where people started really, at least in the qualitative part, we can really see, this is the type of function that is not at least needed, or pilots were pretty clear on that aspect, which is, again, not what we do from EASA side to impose the function, but more to evaluate how to enable them. Yeah.
Okay, thank you, Guillaume. We may come back to that for later, if you wish. But I would like to come back to one aspect of your presentation, Mihály. I think you went a bit quick on that one. That was the current challenges that you are meeting as an NSP, and the use cases of AI, how you use AI to use those challenges. Can you possibly elaborate a bit on that?
Yes. We have, for instance, I know that some of the ANSPs are facing with the challenge of training controllers, and there in the phase of training there is a simulation requirement, and for those simulation they need pseudo pilots, and those pseudo pilots are very hard to recruit them or keep them and train them in the loop, and that way the artificial intelligence like voice recognition and understanding and the machine could be a help for that to bridge this shortage of pseudo pilots. On the other hand, if this technology will develop very much and will be reliable enough, then those guys who are working as pseudo pilots would probably lose their job. So it is one aspect that we have to consider in a way. And I'm sorry, I forgot the second part of your question, or did I answer?
Yes, I think that's fine. I think that's a good example, and I think that when we speak of automation, I think one important aspect with the increase of automation, with the skills which are changing, is the risk of de-skilling. The more you rely upon automation, there's a risk that you lose your skills to react to unexpected situation. So I have a question to you both, because you are on the front line. What is your experience also from the past evolution already of your roles, and what is the perspective for you in the coming years with the increased reliance upon automation? How can we manage the risk of de-skilling and keep that essential element? That is, okay, when there is an unexpected situation, we rely on the human, not on the machine.
If I start, well, I think you do. Well, when we talk about de-skilling from our perspective, it's usually flying skills, and yes, you see, there's a tendency to over rely on automatic systems and on making sure that automatic systems work, or assuming that they work. And of course, so it's very easy to forget that the more automation you have, the more monitoring skills and alertness you need to have as well in order to be able to intervene if automation fails, because also with the complexities of automation, a lot of automation fails very subtly, so you don't really notice. It's like I call it a subtle incapacitation of automation. And so that is something that is a trap both individually for people and of course also in general for organizations to make sure that, okay, they adapt their training, they adapt their, especially in recurrent trainings, how are we going to raise awareness to these possibilities, how are we going to train people and make them aware that we've had these incidents or other operators had these incidents, and how are we going to react to that. And then, it's complacency that is one of a big human flaw, unfortunately. And when we look at AI going beyond automation, I liked yesterday when the guy from IATA said that we need to keep our our intellectual elasticity. And I think we need to make sure that AI will certainly induce some or introduce even more the risk to become intellectually complacent if we have an AI that tells us what's going on. And so, and I think we need to really think about how we deal with this and accept that we have to cater for the human flaws in order to be able to make the most use of the human talents. So I think that is something where we need to look at.
Yes. The same applies to the air traffic control, because when we talk about the skilling in the air traffic control, we speak about the basics, about conflict resolution, traffic coordination, teammates, teamwork, and everything that are the basic skills to provide the air traffic control. And remember that the air traffic control is about deconflicting aircraft. At the very end, you have two aircraft and you want to avoid them to conflict either on the runway or in the air or between them. So one, let's say, fear or something about AI, and it's a legitimate fear, is that we may lose these skills because we rely more on the traffic synchronization, the flow management, that we will have the aircrafts that are expected in the sector. For example, you mentioned 45 aircraft, but what if, from an over-delivery perspective, from something you have 55, 57, can you control them, 55 or 57? And also, skills that are hardwired, strip marking and everything, that we may lose our ability to perform well. So the answer are two. The first is training. It's the level 1 training about all these things. But the other thing, which is deeper, is to include in the design the human factor early in the concept. In the air traffic control, we see a lot of projects that the air traffic controller is brought to the experiments at the very end in the design process. So whatever he or she wants to, let's say, revise may be costly. So for us, it's better to perform early the human element in the design of AI, why we need this, to put the air traffic controller there. And at the end of the stage, also to perform something like a cognitive task analysis. Not only this is the good system and it works like carrying 45 aircrafts and deconflicting 35. The idea is how the system fails. We need new skills in learning and unlearning. It's not something like a new knowledge that is added up to already foundational knowledge. We need new knowledge. Just like we end up, if you go from writing the paper to writing the tablet, it's completely different. You may think that's the same. It's not. The concept is the same, but it's different. New types of errors, new things that if you have it early in the design, and for that, we have drawn in the, let's say, the learnings from the accidents of the aviation, because some accidents, especially in the 80s, were for the root cause was out of the pilots were drawn in the design process late, and they couldn't, let's say, revise things in the cockpit, in the human interaction in the cockpit and everything. So we want to avoid this, and we try to solve this problem with these three approaches.
And then I have a second question for you too that comes to my mind. That is about the purpose and meaning of at the workplace. I remember when I joined the aviation industry, it was in the late 80s. Sorry for remembering those old times, but at that time we relied very little on automation. And I was in the maintenance planning department, and I remember that we had a big room with a huge board, and we had all the aircraft listed with the registration marks and strips of paper indicating the flights that they had to do during the month. And then in the gaps, we had to schedule the progressive maintenance, the A checks and the B checks and everything. And of course, there were always events, operations events, so we had to switch aircraft and then to change all the maintenance schedule. And sometimes we had maintenance events as well, which led to also switching the flights. And it was very lively. It was something very dynamic, and it was teamwork. And there was also a sense of pleasure when we find very creative solutions to find the solution of a multiple equation with multiple unknown. And then later, automation came, and the whole team, with this very social and dynamic activity, was replaced by one person behind a screen. It was far more efficient because solutions were always optimized, much quicker. But of course, we've lost all that, all this social dimension at work, and all this rewarding aspect of finding yourself the solution. And I think that's something that we experience in all domains, and not only in aviation, but in all domains in the industry. And my question to you both is, what is your perspective? What is your experience? Do you think that there is a risk also that with the increased reliance on automation, we lose a bit of the interest of the job, which in turn can raise concerns on how we keep the attractiveness. We spoke about attractiveness, which is also a key safety issue. We need to attract young talent in our industry. So, what's your experience and perspective on this aspect of the impact of automation?
Well, I think initially there's a big societal question, certainly, and we come back to ethics of AI. What are we as society? What are we gonna do with ourselves if we over rely on AI? Is there still a place for us? And of course, that trickles down to many industries, many jobs. And I think that is a very worthwhile question, because if we want to keep the human at the center, and if we want to keep the human in charge, we need to provide an environment where the human can function best, and that means that we give him purpose. We create an environment, and we create a job that aligns with the values that the humans share amongst themselves, and I think that is, and you see that when I talk about the greatest thing about being a pilot is having a crew, being a mentor, being a team leader, being someone who puts these people together, and then, like you say, we take whatever comes to us and we try to solve it. And if we had a really bad day, but we've come at the end, everybody's happy because everybody feels valued and we did a good job. And I think that is something that is at the core. It's also at the core of our safety effort and why we're safe with the human at the center. And the issue is when you talk about and the risk is that when you talk about, okay, now we have one guy and a screen, and it's much more efficient. The problem is that the added value of the human, the team, the value-based, the purpose-based environment that we want to create for human, it's intangible. That again, an accountant, if it's not tangible, he's not going to understand it. And that's the issue. We need to understand that the value of the human in our safety environment is to a large extent non-tangible. But we should not forget that when we try to incorporate AI, because otherwise we might be on a path where, in the end, we build a system where we put the human on the side and the system will certainly not be safe in the way that we expect it to be.
Yes.
So I will add something about the task in the air traffic control. When you have simple tasks, for example, you have 2 aircrafts and you try to solve the problem or not to conflict or not, this is simple task. But the air traffic control is far from it. Every day is different. The radar the primary surveillance radars may be off, the VOR, the jamming, the spoofing, the frequencies. There will be work in progress in the aerodrome and everything. So you have to cater. So every day it's a different day and you have a lot of things to cater. So what the team does best is that they have backup behaviors. They correct and they have collective intelligence in order that to provide and promote the adaptive intelligence through teamwork. They say that, you remember that we did that the last time and it failed. So, or it will make it better if we do this, if we reroute the aircraft, if we coordinate with something. We give up a level more than AI and everything, and this is going to happen because a lot of the work in the air traffic control is teamwork. The flow controller, the supervisor control, the planner, the executive, the assistant, the ground control. They can tackle situations early, even with a blink of an eye or a gesture or something in order to coordinate. You cannot do that with AI and you lose it. You have, for example, to input something and you have to circumnavigate. Personally, we used a new flight data system 10 years ago, and it was, let's say, state-of-the-art or something. And in one case, you have to manually enter all the details of the flight plan, the type of the flight plan, and it was better to avoid and to leave it uncorrelated. So it's against the rules, but you are bending the rules because you have a target uncorrelated, but it is safer because you will probably lose 2 or 3 minutes in order to program the system for an outside of the envelope situation. So sometimes the other guy can do that, you can coordinate with him or you circumnavigate the system, and this is going to happen. And this is going to disappear if we rely a lot of AI. We use the human dimension and the teamness and the backup behavior, the error correction and everything that may make us, as an air traffic control unit, an adaptive unit.
Mm-hmm. Thank you, Stathis. I would have, I think, plenty of other questions for you, but let's have a look now at Slido, because I see that there are also many questions coming from the audience. So let us see that on the screen. So the one that is on top, how is the perceived skill degradation due to AI different to skill specialization as a result of industrialization from the 18th century onwards? That's a question. Do everyone has a memory of what happened in the 19th century and how things evolved? No, we are.
If I may, Jean-Marc, just maybe just a comment. I think there is surely a connection and similarities, but probably one thing that is different is that AI has the potential to, I would say, automatize much more, in the sense a complete end-to-end chain, functional chain. And this is probably the difference. Before we were using, I would say, automatization in the sense of getting, I would say, more less workforce doing something more too repetitive, etc. With AI, we are entering in this notion of cognitive functions of the human, and I think that brings a bit of an additional dimension, exactly like Paul was saying, going beyond, in fact, we see it in the press every day, about even the place of the human in the post, let's say, deployment of AI era. So I think this is where there is surely a difference. Now, if we restrict it to our domain, aviation, I think you understood from the different talks that we are really trying to manage it in a let's say, in a safe way, meaning we are necessarily bounding a lot the effort, and I think we probably don't have too much too many concerns about that within our domain at this stage. That would be my 2 cents on the topic. Yes.
Mm-hmm.
if I could just add quickly, I think it's not that much different. I hope we've become cleverer in the last 200 years in our understanding of what makes human tick. So I think it's something where we need to be aware that it's there, that there are some dangers, and we need to accompany these dangers and the humans that are affected in the right way, so that we can not de-skill but upskill or skill differently. Again, I think it's a way of how we manage the change. Again, thinking about the human at the center of it.
Thank you. And so then there's a question related to the shortage of engineers. Huh? So we have no engineer on the panel today, because we wanted to focus on the flight crew and the air traffic controllers, and I think that was enough, I think, for a panel. But clearly, I mean, the issue is the same for many other professions in the aviation. There is an issue of attractiveness, which is also due to societal changes and the aspiration of young people who is different than the older generation. But then the question is, and maybe it's for you, Guillaume, because you have in mind many use cases of AI. The question is, can AI assist and attract a new type of engineers to industry? Do you think that the use of AI can be a motivation to attract young people to our aviation industry?
I think so, yes, and that was the purpose also of my injecting this information, that even in level 1, machine learning is already attracting actually to the aviation sector data scientists, AI scientists, which we didn't have as a profile in the field. And this is, let's say, the young generation is really a lot going into this game. After the matter of salary, let's say payment compared to other tech, let's say high-tech industry is a question for sure. But that's for any type of job. But we already have different profiles connected now to the let's say, more traditional engineering that we are seeing in design organizations today. Absolutely.
May I add to that point that as the ANSP's one part is the air traffic controllers community themselves, and the other big part is the engineers who maintain all the equipment behind the air traffic control. So I agree with Guillaume that the new available solutions can attract guys to come to the ANSP, but it also comes the question about the salaries, and the other issue is as far as I remember, in my age, when we decided our job, there was an enthusiasm for aviation. And if this exists in someone, that guys will choose the aviation. If not, then only the money remains an issue, but it will last very short time.
Yeah, that's.
I mean. Mm-hmm. That's my.
That's the key issue. Yes. Mm-hmm. Okay. And then we have a question on just culture challenges. How can fair treatment and personal accountability ownership be balanced in the future with high AI integration in our daily work? So that's a question also for you, Guillaume, and also Paul, as you're very much involved in the just culture aspect. Have you already had some reflection on that?
Well, it's a €1 million question, I guess, when it comes to just culture.
Sorry, I don't have the money.
No, but it's a good question. I think we see already today, without AI, how are we going to balance, accountability in just culture, and just culture is the differences in perception on how we treat accountability, even in a just culture environment, is very different from organization to organization. And sometimes from instance to instance. I think it's like before with when we upskill due to AI. I think it's something we need to be aware of. We need to have a structured approach, understanding the challenges we have already now, and then trying to transpose these in what future challenges, what additional challenges are going to come when we have AI. What's going to happen if AI gives you a course of action and you don't follow it and, okay, you crash? What happens if you follow it and you crash? So, I mean, there's a lot of these questions about how will AI be balanced if you still maintain, or how will the influence of AI be balanced if you still retain final authority? And then, of course, if you retain final authority, does the system give you the tools to be up to that final authority and accountability? I think there's a lot of questions we need to deal with. It's not something, I believe it's not something that we can, put in a side point. Yeah, we'll deal with that at the right time. It's something we need to be aware of when we integrate AI in how we work and in how our system. So I don't have an answer. I hope I have confused you enough so you don't ask any more questions.
Exactly. I'm stopping there. No, but Guillaume, you wanted
maybe
to...
just, I fully agree with you, Paul. And I think just culture, we should take it, again, as part of the framework. We should keep the principles we have today. We should maintain them. Again, level 1, level 2, we are a bit in known ground, so probably it will work as long as we define operations that are feasible, practicable. We don't put, let's say, human end users in a position that they cannot cope with their task anymore. We should be able then to still say, yes, you are accountable, and just culture is a key. If we look at the end of the scale that I was drawing, and it's not the end of the scale with AI, but at least for aviation, level 3, we are in really unknown ground on this case, I think, because think about the picture I was mentioning with an operator managing a fleet of drones, just intervening upon alerting. How do you deal with that? I mean, how do you deal first with the responsibility accountability scheme? That's a difficult topic to discuss. But then if you add up this type of dimension like just culture, it's not easy. So I think we have a challenge, and this is one of the key points to take on board. Absolutely.
But if we regard the definition of just culture, I can't quote it word by word, but it considers all the circumstances of the given people facing with. So if we build an environment around that worker which drives him into a failure, then it's only a solution to apply just culture to consider his opportunities or possibilities to choose or solve the question. So I think it is a very difficult question, and it needs, the society needs a certain education on that. What does just culture mean in real life?
Thank you. And so the last question before we conclude, with human performance issues such as mental illness and substance abuse, is the human being the bigger safety concern than the automated system? That's quite a challenging question, but it poses. I think it poses the question of the global approach of the system, the safety of the system, with the strengths and the weaknesses of each element of the chain. And it shows. I think the question shows that we have to think of the introduction of automation and the development of automation as part of a bigger system that also takes care of the weaknesses of the other part of the system. And maybe Paul, as you are also quite involved in those issues of dealing with those human factors aspect, is there anything that you could also add?
Well, I first of all, I don't think the human is a bigger safety concern, because mental illness and substance abuse is a reality in society and also in part of our workforce. But I think it's first of all, it's the outlier. And then secondly, as I think I alluded to before, I think we know what kind of environment we need to create for the human to function at its best and give us its best performance. And I think it is a matter of creating and maintaining that environment for the human to function well. I mean, and it's same with automated systems are working if you do maintenance on them. You know, the human is the same thing. We should not kid ourselves. I don't think it's a question about who is the bigger safety concern. I think the human is the human in the right environment is certainly the best or the bigger safety advantage than necessarily blind automation.
Safeguard.
Thank you very much, Paul. And I think that with this, I think we can conclude the panel. I think it's a good summary, I think, of all the challenges and of automation, AI, and the way we make the best use of the human dimension in the system. So I would like to thank very much the panelists for their contributions and their insights. And I would like also to thank the audience for their attention. Thank you very much.